Okay, this is chapter 3, lesson 2, adding and subtracting linear expressions. So I need you to open up your book if you're not already. I'll open to page 88. So open up your book to page 88. Um, in order for you to do this, you first need to know the vocabulary, and if you don't know the vocabulary, it's going to make it tough. So you need to know that a linear expression is an algebraic expression in which the exponent of the variable is 1. Now that's kind of wordy, but essentially what that means is that if you look here in this table, we have all of these are linear expressions, okay? And then if you look at the bottom table, all of these are non-linear or not. Okay, they are not linear expressions. So a linear expression is an expression, and in our case, we're going to really pretty much be doing binomials, which means you have two factors or two add-ins, okay? In this situation, you have a linear expression would be when a coefficient is multiplied with a variable and the variable has no exponent, okay? If, like all three of these, this is just an x, just an x, just an x, and it could be just an a b, a c, a d, an e, an f, an alpha, beta, or a gamma. It doesn't really matter as long as your variable is only to the power of 1 or to no power, because when it's the power of 1, we essentially leave it as no power. If you have a variable in an expression that has an exponent, like this one, x squared, or this one, x cubed, or this one, x to the 5th, those are non-linear. That means it will not be a straight line. When you would graph it later on in algebra, you're going to find out that that's not a straight line. So we're looking at ones that are linear, which means they only have a single variable. Okay, well, I shouldn't say that, a variable with no exponent. They can have multiple variables in it, but it means it doesn't have any exponent. And then you're going to add or subtract these linear expressions. Now, in order to do that, you have to combine your like terms. And there's two ways you can do it. You can do it vertical or you can do it horizontal. I personally like the vertical method, but the vertical method can be challenging at times. So with the vertical method, what you're going to do is you're going to take your binomial, is really what it is. You're going to take x, and I would change that to plus a negative 2. And then you're going to add that, in this case, to the second binomial, and you're going to line up your x's above each other and below each other, plus, and then 8. Okay? Now you're adding these together. So you add just add like you would normally add when you would have addition problems. So, but you're going to add your like terms. So a negative 2 plus 8, those are both like. They're both numbers. They're both constants. So 8 plus a negative 2 is 6 plus. Then you have an x and a 3x. Now remember, there's an invisible 1 in front of that x. So 3 plus 1 is 4x. So our answer is 4x plus 6. That's the vertical method. The horizontal method is doing the exact same thing except that you commute the order. So if you have x plus, and I'm going to turn it to negative 2, okay, plus, and then 3x plus 8. Okay, what you're going to do when you do problems like this is you're going to make sure that all, and because we're adding, I took out my parentheses because the commutative property and the associative property of addition say that really the order in which you add does not matter, and where you put those grouping symbols does not matter. So, but you have to commute your order. So you have x plus, and then you got to move that 3x over here, plus, and then the negative 2 and the 8 go next to each other. Okay, then you can take that 3x plus x, and I don't put it in parentheses. Your book does, but you don't have to put it in parentheses. X plus 3x is 4x plus, and then a negative 2 plus 8 is 6. You get the same answer, exactly the same, in two different methods. Horizontal, where you just take out the parentheses and commute your order, putting all your variables next to each other and all your numbers next to each other, then combine your like terms. Or the vertical, where you just line them up and add. The benefit of the vertical is that you're essentially saving a step. You don't have to do that step because there's no need to commute your order because you commuted it when you put it in a vertical method where you put your x's above and below each other, and or your variables above and below each other and your numbers above and below each other. Okay, so that's really how you add linear expressions. So what I would like you to do is I would like you to pause your computer, and I would like you to do number 1 and number 3 for me, both of them. Do number 1 and number 3, and when you're done, play your computer and see if you did it right, and make sure that you are writing these in your notebook. Okay, I'm going to start checking notebooks. So go ahead and pause your computer. Okay, number 1. Number 1 is x plus 2 plus 2x minus 1. So I'm going to do the vertical method. X plus 3 is on top, and then I have 2x minus 1. So that's 2x, and I'm going to turn that minus into plus a negative 1. Okay, do the inverse, the additive inverse. Okay, now I add my constants, my numbers. So 3 plus a negative 1 is 2 because the signs are different, so we subtract, plus, and then 2x plus, again, this is, remember, there's an invisible 1 there. 2 plus 1 is 3x. So our answer is 3x plus 2. Okay, if you got that right, wonderful. Number 3. Number 3 had an extra step in there that you couldn't ignore. You needed to distribute that 2. You can't do anything until you distribute that 2. So you had to do, and so what I'm going to do is do this one horizontally. Okay, so it's 4 plus a negative n, because I turned it into plus a negative, plus, then you have to show you distributive step. So 2 times this, you have to take the 2 times negative 5n, and then the 2 times 3. Okay, so 2 times a negative 5 is a negative 10, n, don't forget your n, plus, and then 2 times 3 is 6. Okay, so that's my distributive step. Now I have to commute my order. So it's 4 plus, and then I'm going to move my 6 up here, plus negative n plus negative 10n. Okay, 6 and 4 is 10, plus, and then a negative n would be a negative 1n plus a negative 10. So a negative 1 plus negative 10 is a negative 11n. And that would be your answer. Now, even if you were going to do the vertical method, which is fine, you could, you have to show this step. You are not allowed to skip that step because you need to show that you understand how to distribute. Okay? And if you're going to complain about showing that, I could make you show the distributed part where I could have you do 2 times a negative 5n plus 2 times 3 and make you do that step. And I'm letting you skip that step right now. Okay? But I could make you do it. And if you wanted to do that step, you could do that step if you want, if it helps you. That would be fine with me. But you are required to show that step. And even if you're going to do it vertically and rewrite it as 4 plus a negative n, and then 6 plus a negative 10n, that's fine. You can do that, but you still have to show this step first. Have that written down and then this. Okay? So essentially when you're distributing, it really doesn't make a difference. You're almost, you know, just as easy to do it as a horizontal method. Okay?